Okay, today's lesson is going to focus on writing equations of parallel and perpendicular lines from graphs. Our prior video worked on writing equations of parallel and perpendicular lines from equations. So the good news is the process is exactly the same. There's no difference in process. The only difference is in how we get the slope that we are going to use to write the equation of our new line. So in the prior video, what we did was we looked at the equation and we got the slope that we needed from the equation. What we are going to do today is look at the line that's given to us graphically and find our slope from the graph. And then we're going to write the equation the exact same way. So just remember as we go through with parallel lines today that parallel lines have the same slope. So we're going to use rise over run to find the slope of our given line that's graphed and then use that to write the equation of our new line. Same thing with perpendicular lines. Okay, previously we found the slope from the equation, all right, and then took the opposite reciprocal of that slope to write the equation of our line. Today we're just going to do the same thing, but once again we're going to find that slope by using rise over run from our given line, which is graph this time. Now, the good news is we're all doing the same process, okay? It's all the same kind of things, just how we get that information to begin the problem, all right? So just remember that slope graphically is rise over run, and that all we need is a point and a slope to write the equation of our new lines. All right, so let's just jump right on in here and look at an equation, or excuse me, a graph of a line to write our new equation. So what we want to do, all right, let me pull this back up here. There we go. All right, so what we want to do is write the equation of a line parallel to this line that happens to go through the given point here. So let me scroll down just a bit. All right, so if we look here, all right, our given point is 4, 3. Well, if we think about our point slope form, all right, we have most of the information. We know x1 is 4, we know y1 is 3, so the only information we're missing at this point is our slope. So what we want to do is now come down to our line. We want to find two good corner points. So here's one at -7. Looks like there's another good corner point here at 3, -5, and we want to find our slope. So remember, slope is rise over run, so I go up 2, and I go over 3. So the slope of the given line is 2/3. So now I just have to take this and plug it into our point slope form, just like we did in the prior lesson. So y equals 2/3, all right, times quantity x minus 4 plus 3, all right, would be the equation line parallel to our given line and through this point. And if I wanted, I could go up and just sketch this real quick, so I could go up 2 and over 3 to get our second point. And then I could plot our line, our new line right through that. All right, and you can see that this line is parallel to our given line, and that would be the equation of that new blue line. Okay, now let's look at the same situation, but now we want to write the equation of a line that is perpendicular to the given line and through the given point. So once again, our given point is 4, 3, and we need a new slope. So once again, if we go down, let me scroll here, we're going to find two corner points. All right, so this is the exact same problem as before. So our rise is 2, and then our run is 3. So the slope is 2/3. Now, if we want a perpendicular line, we know that our new slope needs to be the opposite and reciprocal of this. So now, since this is positive, we need this to be negative, and the reciprocal of 2/3 would be 3/2. And then once again, we can jump right into our point slope form of the line that we've discussed. All right, so x minus 4, and then plus 3 on the outside. And there is the equation of our line that would go through the red point here and be perpendicular. Now notice, I could, all right, plot one more point using our slope, so I could go down 1, 2, 3, and over 2. All right, get a second point on that line. And then I could graph our new line. All right, and it does in fact look like we'd have a right angle here, so that's really good. So it's a nice way to check if you have the graph of the point anyhow. You can try and draw it in and make sure it looks pretty much like a T. All right, and go from there. All right, well, let's try another example to make sure we are getting the hang of this before I send you off to do some practice on your own. All right, so now I have to scroll a little bit. Now, we are doing parallel this time, so we want equal slopes. All right, so I'm going to come down here and find our point. Okay, our given point, it looks like is -5, -7. So now I need to find two good points. And remember, we just need two good corner points. That looks like a good corner point there. That looks like a good corner point there. And we're going to find our slope doing rise over run. So if I look, my rise this time is down 1, 2, 3, 4. So that is -4 and over 1. So our slope is -4 over 1. So if we want our new line to be parallel, we need equal slopes. So I'm going to take this exact slope here, which is -4, and I'm going to plug into our point slope form. Now remember, I am subtracting -5 inside my parentheses, so that's going to become x plus 5 and then -7. And there's the equation of our parallel line. So you can see that it's a pretty similar process as before. The only difference is we have to do a little bit of work on our graph to find the slope that we need. All right, so let's look at one more. All right, this time let's do the perpendicular version. All right, now let me scroll down a little bit. Okay, so once again, our given point is -5, -7. Okay, and if I find my two good corner points here again, okay, once again, you can see that this is the exact same line, so down 4 over 1. So the slope of this line is -4 over 1. Now remember, since we want a perpendicular line this time, we need the opposite and reciprocal slope of this guy. So since this is negative, it's going to become positive, and then the reciprocal of 4 over 1 is 1 over 4. Now I can just take this information, plug into our point slope form, and voila, there we are. All good, all right, with our new equation. Okay, so now we're going to go through some example problems. I'm going to have you do some work, and then we'll check that. So let's start with this guy. So what I'd like you to do is write the equation of line parallel to our given line and through the given point. So go ahead and pause the video and do that now. Okay, so this is the equation that you should have come up with. Y equals -5/3 times the quantity x minus 7 minus 1. All right, so let's look at the same situation. All right, same line, same given point, but this time write the equation of line perpendicular to this line that goes through the point 7, 1 again. So once again, go ahead and pause the video and do this on your own. Okay, so now you can see that the only difference between your answer now and the prior answer is our slopes, all right, are opposite and reciprocal. So you should have a slope of 3/5 for this given problem. All right, let's do a couple more of these before we talk about a few more specifics. All right, so once again, here's your given point, here's your given line. So go ahead and write the equation of line parallel, all right, to the given line and through the given point. Pause the video and then turn it back on to see how you did. All right, so the answer that you should have come up with is y equals 1/2 times the quantity x minus 2 plus 4. Okay, very similar situation, same point, same line as the prior example. This time, however, write the equation of line that is perpendicular to the given line and through the given point. So go ahead and pause the video and do this problem. All right, so the answer for this problem should be y equals -2 times the quantity x minus 2 plus 4. Okay, so let's move on and just cover a couple of special cases here. So one is, all right, we want to write the equation of a line parallel to a horizontal line. Now, if we think about this, this is a very easy problem because the only line parallel to a horizontal line is another, all right, horizontal line, okay, which would be this guy, all right. So let me move it up just a little bit so we line up there. There we go. All right, so the only way we can get another horizontal or line parallel to a horizontal line is to have another one. So the equation of the line I just drew in there would just be y equals 4, or excuse me, -4, because we are, all right, below the x-axis, and that's all you have to do. All right, so now, all right, what about if we wanted a line perpendicular to the given line and through the given point? So once again, we have a horizontal line. Well, the only type of line perpendicular to a horizontal line would be a vertical line. So the vertical line that goes through our red point is actually, all right, the axis here. Okay, so this blue line here is, all right, perpendicular to our horizontal line. Now, if we remember, all vertical lines are of the form x equals a. So we just have to figure out what the x-coordinate is for all of these points, and that is, in fact, 0. All right, so horizontal and vertical, you just have to think about what you have and what you need to be parallel and perpendicular. All right, so let's take a look at two more. Okay, once again, now we're starting with a vertical line, and we want our new line to be parallel to this. Once again, if I start with a vertical line, the only way to be parallel is to have another vertical line. All right, so there we go. All right, so here's a vertical line through that point. And once again, we just said that all vertical lines have the form x equals a. What is the x-coordinate of every point on this new line? That would be 2. And finally, one last problem. Okay, this time we want the line perpendicular. Okay, so once again, if I start with a vertical line, the only thing that is perpendicular to a vertical line is a horizontal line. All right, so there's a horizontal line. Let me shift it so it goes through our point here. There we go. All right, so you can see that we get the nice T, we get the right angles, and once again, we know all vertical lines are y equals, or excuse me, horizontal lines are y equals b. So what is the y coordinate of every point on this line? That's right, y equals 4. All right, well, that concludes our lesson on writing equations of lines from graphs. All right, be ready to discuss this and do some classwork. All right, next time I see you.